Hello everybody. Welcome to the webinar. I'm glad you're here. My name is John Wallace. I'm head of business development and sales in Invervis. And today, together with Frank Wagner from Time Extender, we are going to try and tell you and show you, especially how you can break down your data silos and unleash the power of process mining with a combined solution that we have made between Invervis and Time Extender. Hope you enjoyed, and I'm just going to jump into the slides, straight into the slides. We have a short presentation giving you an overview of what we mean by this and how we do it, and then we will hold a demo so that you can see in practice how this all works and what are the typical insights that you can get from using process mining. So we start by talking a little bit about what process mining is, right? So process mining is a discipline of analytics that actually extracts the digital footprint of your processes to show how it's executed in real life. So people have your processes in process manuals or in ISO 21000 manuals or whatever, and they think that they're being executed in the way that were designed. But generally, when you go into the data, what you find is that that is not the case. So with process mining, extracting information from logs and from transactional systems, we can reconstruct how the process has been actually executed. So what these tools do is they visualize the different variants, different paths that the process has followed every time it's being executed, and which generally are multiple. They provide data so that you can actually analyze and explore the behavior of these executions, whether it be individually or in an aggregated form. They allow you to drill down to specific situations and understand why they're happening. They allow you to benchmark between, regions, departments, sites, teams, etc. So you can see the differences in performance between them. They allow you to define KPIs with a process perspective. So you have your standard KPIs, but generally companies lack the process perspective in the KPIs, the why things are happening, right? And we can extract these from the process mining tools, and you can add them to your dashboard so you can have another perspective on how your business is performing. And finally, they can give you insights into the future behavior with predictive algorithms on how things are gonna work and what the impact is going to be. So the typical use cases for process mining are first and obvious process improvement. So you can identify waste, bottlenecks, repetitions, et cetera, to be able to optimize your processes. Also to identify automation opportunities. So you can see how exactly the processes are being executed to locate what are the particular variants or the particular paths that you want to automate, or if there's more value in automating some things versus other things, etc. The other use case is compliance. So if you have a process that is subject to, I don't know, regulatory regulations, etc., needs to be performed in a certain way, you can evaluate if you're actually performing it that way, if you're executing it in the right way, and therefore identify if there's risk to the business, etc. You can predict behaviors and simulate outcomes, and you can enhance your monitoring capabilities, adding this process perspective to your normal KPIs, so you can have a richer view of your business. And finally, you can use it to support IT system migration. So you have a system like an ERP, for example, where it's process-based. You might want to look at your processes before you migrate to the new version. You You might want to see which ones are being actually executed and utilized, which ones not, which ones you might want to modify or optimize before you migrate, etc. And this gives you this view. So how does this actually work? Well, you extract the information from the corporate systems, and basically you need some basic information. You need to be able to reconstruct the sequence of activities. So what you're going to need is a trace ID, which is the unique identifier that links a sequence of activities together to create a process. You need the activities, obviously, or the events that are occurring, and you need some timestamps. Generally, with one timestamp is enough. You can have only one timestamp, but if you have two timestamps, then you can differentiate between durations of activities and durations of transitions between activities. And then are the attributes. These are things that impact the process and that can help you understand and obtain better insights when you're analyzing it. So things like who's performing it, things like what are the resources, what type of product or service are you talking about, where it's being performed, etc., etc. And the more attributes you have, the richer the insights you can get from the process mining. So this seems simple enough, the data model of process mining. The difficulty here, the challenge, is actually populating this model, which is very simple. And this becomes even more difficult and more challenging when you're talking about a process that crosses several systems. If you have your process that's contained in just your ERP, for example, it's easier to access the information, to know where the information is in all the tables, and then to just construct a coherent view of the process from there. But if the process starts, for example, in a CRM with the order, and then it goes through a manufacturing execution system for the production of the goods, and then it goes through a logistics system that manages warehousing and shipping, and finally into the ERP where invoicing is done, then it becomes a real challenge to understand where the information is stored in all these different systems, and how to put it together to construct this coherent view of the end-to-end process. Now, this is where the real challenge is. And this is precisely where a tool like Time Extender can be of enormous value. So now I'm going to pass on to Frank Wagner from Time Extender, who's going to tell you a little bit about how this can facilitate obtaining this data.
Yeah, thank you. Thanks, John. So exactly this is what we're looking at when we try to do what John was speaking about in reality, right? So you have your different systems which contain parts of your data, but to bring it all together, you end up building out those what I call spaghetti monster pipelines, right? So you need to get the data from the data sources, which are increasingly diverse, relational systems, flat files that you need to enrich the data, but also cloud data sources in this schema on the left-hand side. And you need to get them over to the data consumers in variables for process mining, reporting front ends, like Power BI, Tableau, or Click, or other use cases. And in order to get it from the left to the right and to make it a coherent data set and combine them together in the way that makes sense for the business, you end up building those data pipelines, which are hard to build, but even harder to maintain and to operationalize. The reason for that is that you have to deal with several technologies. You have to have a very specific skill sets in your team, and those are hard to get by. And then also, of course, you have a lot of requirements that you want to ask from your data, and that is why you end up building these pipelines, and it's really a mess, so to speak. However, if you look at it from a different point of view and try to automate it and go into a much more agile and operationable way, this is where Time Extender can really help you speed up this process and make this a much better experience. And this is what we do. We are in the market since 16 years now. We have a customer base of 3,500 customers around the world using our data integration automation platform. So we help really customers automate their data management to a degree that it becomes manageable again with a decent amount of skills and people, instead of having to have a whole army of data engineers, etc., to keep it manageable. So of course this spans across all the industries. So I have highlighted 4 customer cases here, but there's a whole lot of industries. All the industries are affected by this and have the same needs basically. And this is why we are distributing our solution around the world through a network of trusted partners, and Inverbis is one of our very trusted partners who helps customers, leverage their data to get the insights from it that they need. And this is what we think it should look like. Instead of building out in a manual way with a lot of technologies and a very complicated way, the spaghetti pipeline monster, we think you can have one automated tool that gives you in one interface the ability to do the entire data management life cycles from beginning to the end. So we start on the left-hand side with 250 data connectivity options where you can connect to your existing systems, relational databases, cloud data sources, flat files, and combine them all together, ingest the data, decouple it from the source, bring it into your analytics realm, on all the technology options that we have at hand, then model the data in the data warehouse, relate it together, clean it, apply data quality rules, etc., apply transformations, also enrich it with additional attributes that we can then leverage in Inverbis to gain additional insights, and then later on deliver the data from the warehouse to the use cases, push it out to Inverbis, push it out to my analytics front end, so I can really gain the insights from it in the speed that I really want. We do all of that on a metadata level, which really gives you the speed during development and the agility that you need to make it to keep it flexible, but also that also allows you to do it in a repeatable way, so that you can operationalize the things that you build in a really efficient way. So that's what Time Extender gives you, and then how does it fit together with the Inverbis platform? So it's actually a perfect fit. So we go from the unstructured and structured data sources on the left-hand side. We connect to the data sources. We decouple it, extract it to the ODX, the Operational Data Exchange, where we land and stage the data. Then we bring it together in the data warehouse, make it behave, bring it in form, shape it. And then we push it out to the semantic model, push it out to Inverbis, upload it there, get all the insights from the process mining platform that we will see in a second. But then also from there, where additional insights are gained, we can also feed it back again into our data management process, and then deliver it, let's say, to business users that don't have access or the knowledge on process mining. And now I think we have prepared a showcase.
Yeah. So I hope this gives you a quick overview of what this is about, but I think it's better that we show it in a practical way. So we have a small demo here prepared for you. What we have is we've created a demo based on a real sort of situation, but this is a demo. And what basically we have here is a telco. Let's call it Telco X. And we're talking about the incident management process, which is split into 2 systems. So you have your incidents, your customer service incidents that are recorded in the CRM, where your customer service representatives take the calls in a call center and record that in the CRM. And if there needs to be an intervention of a field service team or technician, that is managed in a separate system, which is the field service management system. Right. So we have the data that we want for the end-to-end process split between two two separate systems. So what we're going to do is we're going to apply time extender to process this data and load it into the Inverbis platform, and we're going to show you how time extender can access the data from both systems, from both sources, how to use time extender to do some transformations to get the end-to-end process set up, how to load this data into Inverbis, and then I'll briefly go into Inverbis and show you some of the insights that you can get, and then go over a Power BI dashboard that is created with this data. So without any further ado, let's start with the demo. Frank, you're muted.
I'm sorry, that's a rookie mistake. So the first thing we talked about is data connectivity. So I need to connect to my actual data sources, the silos, so to speak, where I need to get the data out, right? And that's the first challenge. So Time Extender has a whole portfolio of more than 250 data connectors that you can choose from. So basically you can get the data out of all the systems that you have. I have configured just a couple of them for you to see here. It's just some examples. As I said, the list is very long. So let's just see what we have here. For example, of course, there's SQL data sources. For relational systems, we can do REST APIs. We can do CRM systems with a more tailored connector, for example, dynamic CRM. We can do, of course, Excel files. We can do flat files like CSV or JSON or whatever you have. We can do Postgres, SQL, of course. We can do ITSM software ticketing systems like Jira. We can, of course, connect Oracle sources. We can have SAP available. SharePoint is an all-time favorite, of course. ServiceNow is available, XML files. So I think you get the idea. The list is super long of all the connectivity options that you have. So this is the first step. You need to connect to the data, and basically in here you configure your connection string. So this is the web component of Time Extender. And once the connectivity is established here, so the connection string is configured in the right way, we can jump over to our modeling client. And that looks pretty similar to what we've seen on the slide before. So we have the three layers in here. We have the so-called ODX, right? So the staging or data connectivity area. In the middle, we have the data warehouse where we collect and relate the data and transform it and bring it into shape. And then in this case, we have here the execution where we have a component that will upload and push the data out into the Inverbis platform for the process mining insights. And in here, now you can see several data sources are already configured on the ODX side. And in the data warehouse, we have already one data source in here, which is the field service events. And that comes from the field service data source that John just mentioned. And also the fields you can see, like we described before, you have the trace ID that will relate all the steps of one individual process together. And then the individual activity IDs, and then we have start and end timestamps, results of what has actually been done in this incident, etc., etc. So let's add the CRM data. How do I consolidate the information from the two systems together? So first step is to add a new data source here. I will call this my CRM. And now I can choose from the connection strings that I have configured in the portal. We have seen before. Here's just a subset of those. Of course, you can then have a very long list of all the connection strings available for you. Now I'm already connected live to the system, and I can really get an idea where the right information is that I need. So you can see a whole list of the tables in here. We can get now a preview of the table already and really do queries and then really see what it looks like. Okay, trace ID, activity. So this looks like a good fit. I also have timestamps in here, right? So this is exactly what we need to perform the process mining step. So this data looks exactly like what I need. This is my CRM data. I include it. I can then even go one step further and could decide to include or remove specific columns if you have sensitive data in here, PII, etc. So you can be very specific about what you want to load. In this case, I will load all the columns. And then I will add a transfer task because, as I mentioned before, we try to do in-time extender as much as possible, as long as possible, based on metadata, and only move data when it's really necessary, because it can be pretty expensive to move data if we're talking about large amounts of data. And this is why we try to be mindful about doing it and only do it if really required. So now I perform this task. I really move the data to my staging area here. And now we can include it in our data warehouse. So we have a new data source here. We can inspect it. The new table is in. And now all that I need to do is to drag it over onto the existing table. Now I get different options how I want to consolidate the two. In this case, I go with Smart Synchronize. And it will add a second mapping to my table. I get a message up here that the table now has two mappings. Whenever I see this message, I know the table is not even. So not all the columns of the table have the same amount of mappings. I can also see which ones don't have the right amount of mapping. So start and end could not be automatically mapped. And also the call center down here could not automatically be mapped. But that's not a problem. We try to apply as much automation as possible, but of course we always leave you the flexibility to add something where it makes sense. So in this case, I will just go to the new mapping and I can see over here which columns I have available. In bold, the ones that are already mapped, and in regular font, the ones that have not been mapped. So now I can just add to the mapping by dragging over the begin column on the start column, right? And those will now be mapped in here. If we open up the start column, it's now mapped from the start column in the field service data source and from the begin column in the CRM data source. Let's do that also for the call center column. So that's the last one that's missing. And now the table is even and the message goes away. So that is perfect. Let's add another transformation step to get some additional attributes on that we can then inspect also in the process mining step. So let's say we have 400 actions, possible actions, like replacing a router, sending out a technician, rebooting something, or replugging something in the data center. So there's a lot of different activities that can be performed as a service result. However, I want to look at them in more broader categories because 100 or 400 event types can be overwhelming. So because of that, we want to introduce a broader category in here. I have prepared a lookup table already. It has no data in it yet. So I could load this from a CSV file, from some master data management system, from a SharePoint list or something. In this case, I will just load the data from an Excel file that I have here locally. So I go to custom data, import data, and then just point it to my Excel file, which has two columns, the actuation results, so what has been logged in the CRM system and in the field service system, and then the action type, so the broader category that I want to look at the data in. So I just load the data. That is what it looks like. So from these values, we will translate into these broader categories here. I confirm that. And now I just need to relate those two together so they are available in the data set that we will upload. So I create a link on the actuation result column. Yes, please. So this is now part of my metadata model. So I can repeat this step, and then I denormalize the actuation result, sorry, the action type to my table here. This gives me a lookup field with the relation that we already put in place. So that is very cool. This will work now. So until now, we have not changed anything. We have not broken anything. Everything still works because we have only made metadata changes. Only now will I click on deploy and execute to really get the new structure out to my database and populate it with new values from the CRM system. All of this is, of course, version control. So you have all things under control, when to go back, if an error was made or something like that. So you have a full version history. So let's just say we added the CRM data. Now the new code is generated. And then also the new orchestration is taking place. Time Extender does all of that for you. So if we now inspect our table, we can go in, we see trace IDs, we see activities, of course, and we see the actuation result over here, but we also see the new action type, our new category, on a more broader level over here. Let's do maybe one more thing with the action type and look at a summary of the data that we already have. So let's say action type summary. And this, of course, is like a preparation step for, let's say, for analytics. In this case, we do process count, and we do step count maybe. In this case, we do the string count. So how many service calls do we have and how many steps do we have in the process steps. Let's confirm that. Again, process the result and then preview the table. And now we can see in the new categories that we introduced a summary of the data that we have. So how many processes do we have? How many steps do we have? And that is already useful now to consume in a reporting front end. But of course, now we want to look at the process mining side of things. So what I need to do there is just trigger our API that we have with Invariabis. I just execute this, and this will push the data set out to John, and John will tell us more about what you can do in the Invariabis platform.
Okay. So thanks, Frank. As you just saw, actually getting this data from two different sources and pre-processing it to be able to populate the data mining model was very simple, very straightforward, and especially very repeatable. And it's something that facilitates and helps out when you have more than one source and when a process is crossing more than one system to obtain a coherent end-to-end process depiction. So now, as you can see, a new data set has been created within the Invariabis platform, within the process mining platform. I'm going to click on it, right? And here we are. We have our first depiction of the process. If we go to the trace viewer here, we see all the information that has been brought in through Time Extender. So your trace ID, your activities, your timestamps, and a number of attributes. Here's the action type we created within Time Extender. We have the result of the field service visit. We have the group in the call center that attended the call, the result of the call center, etc. A series of attributes in here. So if we go back to our model explorer here, what we see is we have our first depiction of the process here. We have 5,540 cases, which go through 18 different paths, 18 variants, 18 different ways, and with an average duration of 2 days and 20 hours, right? This first one looks like the standard way of processing an incident when it is solved directly by the call center. So you create a new incident. It's assigned to a group within the call center. They work on it, they solve it, and they close the incident. So this is what we call the happy path. This is the standard way of processing this. We can also see it in duration terms. So we've had 1,989 cases go through this process. And we see here the durations of the different activities. It's interesting to see that they take on average 5 minutes to actually solve the issue that the customer has given them. But this is just one of the 18 variants. So if we go to a variant browser, it shows us all the variants ordered by number of executions. This is the most executed one, the one we just saw, but we can click on others. Now this is the second most executed variant, 1,500 times. And here, what we seem to have is the same happy path, or the standard way of processing an incident when you have the field work, the field force involved. So you create the incident, it's assigned, the call center tries to solve it. They can't, so they open a work order. This is then scheduled and confirmed, and then the team goes to the client's premises. They execute the work, they close the work order, and they close the incident. So this is the sort of standard flow of how this incident will work. Now we can also look at it here in terms of durations, like we did the other one, and we see something interesting already, which is that the time that the call center takes in actually trying to solve this incident is lower than the one that we had when they solve it. It's only 3 minutes. Now this can mean one of two things: that they really have a very good way of analyzing which incidents need to go to field service because they can't be solved online or in the call center, and therefore they take less time to create the work order and send it to field service. Or it could also mean that they're just not really analyzing the case and just pushing these incidents over to field service and getting, let's say, rid of them without too much analysis. Now, in order to dive a little deeper into this issue, we can use our filtering system here. And the first thing we're going to do is we're going to filter the cases that are not solved by the call center, because that's what we want to look at. So there is a call result that is called report opening, which is when the call center opens the work order. They set it to that. So we're going to filter by this filter, right? And this filter is only giving now I only have 3,480 cases. It's giving me only the ones that actually end up in field service. And now I'm going to add another filter. First, I'm going to save this filter because I'm probably going to need it later. So let's call it field service. Right, so I save this filter, and now I'm going to add another filter to try and see if it's being just pushed to field service. Sorry, this is not the. If it's just being pushed to field service, or if there's something else behind it. So what I'm going to do is I'm going to filter the result of the work that field service does by an item called no fault. Right? This is what field service team declares when they went over to the customer site and they didn't really have to. Oh, sorry, I got the filter wrong. So I'm going to add my field service filter, and then I'm going to add the no fault filter. Now this is what, as I said, what they declare whenever they get there, and they don't really have to do anything, or they can do a simple configuration or something like that. It wasn't really something for field service. It could have been solved online, so that they declare that as no fault. So filtering through this, what we get is that quite a few of these cases, 1,161, actually end up in no fault. And more interesting, the in progress duration is even lower. It's 2 minutes. So this is strongly suggesting that what these people in the call center are doing is just pushing off incidences to field service without really analyzing them too much, because a large number of them end up in no fault. So that's already an insight that I can get from this right off the bat. So going back to our variant browser, we have the two first variants. If we click here, we have a third variant, and here we already see a loop that generally happens when the call center sort of solves the issue, but some time later, and we can see the time here, 6 hours later on average, the customer calls back again because it's still not working. So again, it goes into in progress, and then they open a work order, and it goes through the field service flow. In order to identify these loops, we have a loop inspector here, right? And the loop inspector highlights the loops that are found in the whole data set. So in this case, in this data set, we have three different types of loops. We have the one we just saw, which is the reopening, of the incident because it wasn't solved in the first instance. We have a second loop here where the visit is scheduled, it's confirmed, the team goes over to the customer premise, but then something happens and they have to go back, reschedule the visit, confirm it, and go back again. So they have to repeat the visit, right? And the third loop we find here is one where the visit is scheduled, but it's not confirmed. It goes directly to execute the work order. And obviously, well, something happens, the client didn't confirm, so he wasn't there or whatever, so they have to go back, reschedule it, confirm it, and then visit again, right? So here we're seeing some strange behaviors in the data set in the loop inspector. Another thing that we can do here is we see all these loops, and we see durations here of several hours. What we can do is check for the SLA fulfillment. So we can add a filter here. First, we only have an SLA for the field service incidents. So we have to filter again, just to filter out the call center solved incidents. So we get only the field service ones, and we can add a filter here in terms of duration to see which ones we have an SLA of 4 days to resolve the incident. So I'm going to set here this to 4 days and add the filter. And there I have all the cases that were solved that take more than 4 days to solve. As you can see, there's quite a lot of them. Again, we're not hitting that SLA very consistently. We have 1,832 cases where we're missing that SLA. But interestingly, even when we perform the process as it was designed, this happy path, and we can hit duration here, we are not missing the SLA. We're missing the SLA in 558 cases. And the first thing that comes up is there is a 2-day delay between opening the work order and scheduling. So that is certainly impacting the SLA, and that is certainly somewhere where we can focus to improve this time and to meet the SLAs. So now this is just a very, very brief overview of some of the insights we can get. There's quite a lot more in here through filtering, through getting alerts, where we can set alerts for things like this, for when it's taking more than 2 days to schedule the visit. It can show an alert if we're having this working in real time, etc. But since we don't have that much time, I want to show you how we can even dig deeper into these insights with our dashboards, right? So for these types of cases, we build ad hoc dashboards, which are tailored to the situation of each of these projects. And here, what we have is a very basic dashboard that we've built for this demo. It's called TelcoX Customer Service Dashboard. And what we have here is, on the one hand, the SLA fulfillment we were just talking about. As you can see, the global overall fulfillment is only 47%. There's 58% that were not meeting the SLA, the 4-day SLAs. And since we added this field with time extender, we can actually check. There's two groups working on this in field service, the installation group and the repair group. We can compare their performance towards the SLA. So I can see how the installation group is performing. And as you can see, they're performing worse. They're only meeting the SLA in 28% of the cases. And if I compare that to the repair group, they're performing a little better. They're meeting the SLA in 41% of the cases, but still not very good. Here we have the durations of the cases when field service is involved, the same duration of the cases when they're solved by the call center, and a view of the duration of the transitions, the transitions between steps in the process. And down here we have some attributes, the call center, the result of the case, the group that attended the call, and the type of issue that was reported, right? So here, for example, as you can see, the transition that we saw earlier from the work order to the scheduling, which is the longest, the one that takes the longest, we can press in here, and then we can see, for example, here that the group that attends to the internet issues is the one that is actually taking longer to schedule these visits. It's almost double than the other attention groups. So we can start focusing on where the problems are, right? Here on the left, we have a representation of the variants that you saw earlier, that we were discussing earlier. And here we can look at individual variants and try to understand through the attributes what's happening in them. So, for example, if we click on the first variant, which was the, let's say, happy flow when field service is involved, here we can see the no fault issue that we detected earlier, a large amount of cases that are actually declared as no fault, and we can see that again they're mainly related with internet connections, for example. So we need to work on that. We can also click on the next variant that we have. And here in this variant, if you remember, what we had is the reopening of the cases, the loop where the case was reopened. And here you can see that the type of issue reported here is mostly around the router. So this can tell you that probably you have to improve the way a call center handles router incidents. That they're probably just asking the customer to reboot the router, and then from there they think the problem is solved, but it gets back to them, and so forth. We can go through the different instances and see what is happening. For example, this variant is the one where there was no confirmation of the visit, and what we can see here is that the Valencia call center is the one that's really not confirming these things. So we have some work some improvement there in the Valencia call center to get them to actually confirm these appointments. And we have a second tab here in the report, which is our prediction tab. Now we have a predictive algorithm that we've trained with the historical data associated to this case, and it's designed to tell us what the risk of breaching the SLA is, right? So it's going to predict the duration based on where the actual execution is stuck. So where in the process that execution is. Based on that and the historical data, it's going to predict how long it's going to take to finish the ticket, and therefore if we're in risk or not of missing the SLA. This we have categorized into 4 categories. So 0 is that there's no risk of meeting the SLA. 1 is that there's a little bit of risk, and so on. As you can see here, we have a summary. So we have 31 cases that are active right now that are not going to miss it, but we have 235 that have a slight risk of missing the SLA. So with this, we can actually look at this and understand which are in risk of missing the SLA, and we can take actions to ensure that we are actually meeting the SLA or maximizing the times that we're missing the SLA, right? And I think we're out of time, so this is basically. I hope this gives you a basic overview of what we can do with the platform and how a time extender can be very, very helpful in putting together the data that's behind this, where you can get these insights. So now I think we have some time for questions. So it would be I'm going to stop sharing my screen, and we will be extremely happy, Frank or myself, in answering any questions you might have around this. Okay, so there's a question from Tamara Lucas. How do I know which transformations have been applied?
Yeah, so I think that's for the time extender side of things. If we can go to my screen just for 1 second, I think that's really the power of the metadata approach that we have. So as I mentioned a couple of times, we do all the things that we do based on metadata, and this really gives you a blueprint of the process that we have. Very much like the process actually that we've seen in the process mining, I can also look at the flow of data and the transformations that are applied. So I have created just one additional field here in my table. But you can do this with all the fields that you already have in here. And at any point in time, at any place in the project, you can look at the data lineage. And what this will give you is really an end-to-end view of where the data is coming from. So for example, this is the end result, and then it goes through these transformations. They are applied if these conditions are met, and they are based on the actuation result in this case, and then they go back, to the data sources. And this is the way that how you can see in a very visual and easy and intuitive way which transformations are applied, and that's through the power of metadata.
Great. Right. So Sonia Martinez is asking, how does Enverbis feed back into Time Extender?
Right. Yeah. Right. I think we have discussed the whole portfolio of the connectivity options that we have, and Enverbis is built as a very open platform that offers APIs to get to the insights that have been created there, and then I can just connect those APIs as a new data source in Time Extender and close the loop, basically, get the data back from there, put it into my repository in my data warehouse, and then, for example, feed it to Power BI like we have seen today.
Yep, exactly.
Yeah.
Thank you, Tamara. Somebody is asking, what is the maximum number of events that can be managed with good performance? Well, as a good Galician company, we have to say it depends. Basically, it depends on how much resources you throw at it. Enverbis is operating on the cloud and is fully scalable, so you can scale the platform to be able to process potentially any number of events. It just depends on how much you want to scale it. We haven't had any issues with the events we've been processing, and we've been processing millions of events with the platform. So I'm not going to say it's infinite, obviously, but it's just a question of scaling it.
Yeah.
Gonzalo is asking, how is it expected from the prediction of non-compliance with an SLA? For example, trigger an automatic action. There are several alternatives, but which one would you recommend? Uh, Not sure I completely understand it, but of course, the idea is to take action when you're seeing that you're not meeting the SLA. So um, uh, I would say it depends on the duration of the process. So if you have a pretty fast process that's going to end pretty quickly. Uh, so let's say, for example, you have an ITSM tool, I don't know, ServiceNow, and you're solving an IT incident or something like that. Then you want to make sure that you get an, an alert or an automatic action is triggered to the supervisor or whatever so that they can take action. In a case like this one, where we're talking that our SLA is several days, you can probably get away with just having your Power BI report and checking it, every day and making sure that whatever's at risk, you're taking action at. So it depends a little bit on the time frames that you're working with. We can certainly trigger all kinds of actions through our APIs, whether it be sending emails or whether it be integrating with other automation tools to trigger automatic actions. We can certainly do that, and it just depends on that. Okay, so if there aren't any more questions, I think we'll close it here for today. Of course, if you have any further questions, if you would like to see, a one-to-one demo or a particular demo, or have a meeting or explore the possibilities of time extender, of Inverbis, or of the joint solution, please give us a shout, get in touch with us, and we'll be extremely happy to help you with that. And with this, thank you, Frank, for participating in this webinar. And I hope to hear from you guys again soon.
Thanks, John. That was super insightful. Thank you.